Hi, this is Mel. Today I'm going to talk about a quick summary of chapter 21 about integration. This is VCE math method, unit 1 and 2. Okay, so about integrations, we now assume that you know the integration of x to the power of n dx is equal to this formula, which don't forget the plus c over here. This you should be very familiar with. And with this, let's talk about the approximating of area under the graph. So there are three ways of approximating. One is left endpoint and right endpoint and trapezoidal estimate. So these are the formula for each of them. It's actually very important to know why is it called left and why is it called right. So let's take a look at this picture over here. So it's called left endpoint estimate only because if we draw a cube over here, if it's called left endpoint, then we start from this left point over here to take account of this shape. And for this one, we also take the left endpoint. So this is called left endpoint, and this point is called right endpoint. So if I want right endpoint estimate, I should draw something like this in the pink one, something like this. So I take the right endpoint. So I take the right endpoint. These are called right endpoint estimate. We're estimating the area under the curve in purple, under the curve from x0, which is a, and to b, which is xn. So this whole purple area, we are estimating this one. So we use the multiple squares to estimate the whole total purple area under the curve. So it's very interesting if you think about if the curve is rising and if the curve is going down. So if the curve is rising, then which area, the left or right endpoint estimate, will be larger. So let's take this picture over here because it's rising, okay? If we have left endpoint, so we start from here to draw a rectangle like this. This is left endpoint, right? But if I want to do a right endpoint in purple, so obviously the purple one is larger. So if the curve is rising, then we have right endpoint estimate larger than the left endpoint. In contrast, for the decreasing one, we'll have the opposite answer, okay? And for this equation over here, it's talking about a shape like this. It may not be very obvious to see. Maybe I'll redraw a curve, like more. So a shape like this. So you take this point, the left point and the right point, and draw a line between them. And this shape, estimate another area under the curve, and this type of estimate is closer to the actual area under the curve. Okay, let's move on to what's definite integral. The definite integral is the signed area. enclosed by the graph of fx between x equal to a and x equal to b is denoted by integral from a to b. Note that a is at the bottom and b is at the top. Fx dx. Okay, so if we have definite integral, then what's indefinite integral? So it's actually like this. So without the boundaries, we don't have boundaries. So one important thing to note that is for definite integrals, we actually get a number. But for indefinite integral, we actually get a function in terms of x. Okay, let's focus more about definite integral. So here's the equation over here. So the definite integral of x is equal to the fx from a to b. What does fx mean? So f is any antiderivative of f. What do we mean by any antiderivative? So remember when we talk about x to the power of n dx is equal to this one plus c. So this plus c, it can be like plus 1, minus 1, plus 2, plus 3, blah, blah, blah. So any means any. So it can be plus 1, it can be minus 1. So for any of these options, it's the same. Because if we look over here, so if we have, for example, plus 1, so the c is 1, right? So we actually have a function like this. Plus 1 with when x is equal to b minus plus 1 when x is equal to a. And somehow the plus 1 and the plus 1 cancelled out. So it does not matter like which option do we choose. If we choose plus 1 or plus 2, it doesn't matter. So it cancels out. So this plus 1 and this plus 1 cancel out. So only left with fb and fa. So it's a general form of the antiderivative of f. Okay, so obviously fb minus fa is a number, right? So if we substitute x equal to b and x equal to a, which a and b are all constant, right, into this function, then we should get a number. Okay, so always remember, for definite integral, you get a number. For indefinite integral, you get a function, because you don't have to substitute anything into the indefinite integral, so you have a function. Okay. Now we're moving on to finding areas. How do we find areas? Usually we are asked to find areas under the curve. For example, in this graph over here, we denote this area called A1 and this area called A2, okay? So there are two types of ways that they can ask about us. What is the total area under the curve from x equal to a to b? Then our answer should be a1 plus a2, where a1 and a2 should be positive because they are areas, right? There are no negative areas. What if they ask about the exact area? So it's actually minus a1 plus a2. Why is it minus? Because when we are talking about the exact area, we're talking about the sign, right? So A1 is under the curve, so it should be negative, okay? Because the integral, the definite integral tells us this area under the curve should be negative. So the exact area should be A2 minus A1, and it equals to from A to B integral of, let's call this function fx dx. So it should be equal to this one, which in other way you can write it as from A to C and then plus from C to B. Okay? So in other words, this part is equal to minus A1. So it's not about the area is actually negative, it's about the integral we are taking is negative. Okay? So just remember the exact area. When they ask about the exact area, they're asking about definite integral. So when you take this integral, you'll get the exact area. That's very important between total area under the curve and exact area under the curve, between lower bound and upper bound. Okay, as you can see here, if fx is smaller or equal to 0, which is this part over here, okay, we have definite integral with a minus sign in front. Okay, and from this graph, another thing to note is that it's always useful to draw a graph. If they ask you to find from A to B fx dx, if they tell you A1 is equal to A2, if they tell you this is the truth, then obviously it's 0, right? So negative A1 plus A2 equal to negative A1 plus A1, where A2 is equal to A1, right? So it's 0. So this is about symmetry. Okay, here are some properties of definite integral, which is very important, but like it's logical, so you don't have to actually remember it. Let's start in detail about this. This one is about the upper and lower bounds. So if we have from A to B, then it's equal to from A to C and then from C to B. This one, if we have upper and lower bound equal, then the integral is equal to 0. Actually, if you think deeply into this, it can be explained by, if you want to draw a graph. For example, we have fx like this, and we have A over here. Lower and upper bound all at the same line. It's a line. Remember, when we talk about integrals, we're actually finding the area under the curve. So do lines have areas? The answer is no, right? The area of a line is 0. So the integration from A to A of fx is 0. Okay, this one, we can take the k factor out. What about this one? So it tells us, let's look at plus first. Okay, plus. If it's plus, then it tells us if we have two functions, the sum of the two functions and then take integral is equal to the one of the function take integral plus the other function take integral and then sum. Same for minus. If there are minus over here, then fx minus gx and then take the integral is the same as fx take the integral minus gx takes the integral. And this one is pretty important, which tells you about the order of bounds. So if it's from A to B and then you change it from B to A, then you have to add a minus sign over here. So if you integrate the function backwards from B to A, then you are actually getting a negative area. Okay, so this is the summary of chapter 21, integration. And this is small, so yeah, I finished.